Well, thanks for having me. I appreciate the opportunity to come in and chat. I'll also say that although of the slides that I have today, they are approved by public release by DARPA, the same holds for me, in that many of the comments I'll have at the end do represent my own views. I don't speak for DARPA. Of course, the way DARPA is made up, none of us do. We're all on our own. We all have our own agendas in terms of our opinions about research, I should say. That's one of the great things about the place. So yeah, what I wanted to talk to you about today is one of those programs that was with the acronyms that Joe Reed talked about earlier. And it essentially comes down to, we try to operationalize this question of how do you implement AI and ethical AI. Dr. Krebs raised the question in our last talk about, don't you have to get it in on the ground floor in order to make it work? Well, we at DARPA don't like to, we're not in policy. We like to look at technical questions and examine things in terms of data. And so we set out to ask that question in terms of another program called URSA, or Urban Reconnaissance Through Supervised Autonomy. Through the process of exploring what would developing an ethical AI system look like, we have essentially, I've been quite surprised, we've overturned a number of, I think, implicit assumptions we all might share about how AI is, what an ethical AI system would necessarily be, in terms of its capacity to be ethical, its whether it necessarily needs to be a constrained version of a full AI capability, who contributes to that ethical building process, and how much time it takes, or the chronology. Time isn't quite a C word, so it didn't fit, but the chronology of how long it takes to actually create a system that is LME compatible, or legal, moral, and ethically compatible. I'll get to that in a minute. I think for some framing, I'll start with just the program itself. If you'll bear with me, I hope that there we go, that the Zoom powers that be will let me share my screen appropriately here. Is that coming through? Yes?
I can see it, yep.
Great, thank you. All right, essentially the URSA program, I mentioned, we started from the position, and this is a War on the Rocks article that came out in the process of working this program in phase 1 of the program. We were working from what I call the paper to prototype stage of the program, where we were saying just what is the functional architecture, what should it be, and then building and simulation, putting the pipes together, initial stages. If we expect AI systems to reflect the ethics of human society, we should then also consider where we get our own ethics, morality, and sense of the law. And the truth is that we all do as part of society. We are held responsible for actions legally. And then and expect to act in moral and ethical ways, not just because we take job training that tells us to, but because that's part of what being in a society requires. These lessons are even further expanded and indoctrinated in terms of the warrior and service specific ethos. And we think in so doing that we also have to consider AI enabled systems in terms of that lens, right? So it is inherently a tool and should therefore be an extension of this inherent virtue that we see that our warfighters should have when they are working downrange. So we want to approach AI the same way. In order to understand the lessons learned in the program, I'm going to provide you from this DevEthOps process, as we've coined it, which is a riff off of DevOps and DevSecOps. And the concept, again, is to build these things in at the ground level. This is the program itself, and you'll see quickly why we needed to tackle LME issues early on. Essentially, we were dealing with the challenge that right now urban environments remain among the most lethal for our warfighters to work within and around. Current ratio is essentially 5-to-1 for a team of Marines to neutralize a single shooter in an urban environment. And this is not a ratio that we are comfortable with. One example, a gunnery sergeant would ride his turret in order to draw fire so his other squad team members could locate a shooter. And that is not a concept of operations we want to indoctrinate. So how can we, with technology, overturn and invert this ratio? The insight here was, can we use a combination of relatively small form factor, I'll try to not use as many acronyms, unmanned ground systems and unmanned aerial systems in networks with one each other, both moving in and around these spaces and also equipped with various sensing, perception, and reasoning technologies in order to invert this technology, invert this ratio, dealing specifically with the complexity and with the ambiguity of these environments. The complexity is just the sheer density of the environments, the fact that traditional ISR can't see around objects. Also the ambiguity, and this is really the hardest problem, and it speaks to something that Dr. Jetty mentioned earlier, is that passive ISR really has a difficult, passive reconnaissance has a real difficult challenge trying to disambiguate when somebody is not dressed as a combatant, not complying with Geneva Conventions. How do we determine between somebody going about their day and somebody who means threat to U.S. forces? The insight there is that if we have robots in and on the ground, these vehicles in and on the ground, if they can interact with populations in the same way that a beat cop might interact with the community that he or she serves, can we get a better sense through sort of limited hypothesis type testing of what that person is up to? Just a quick example to make that concrete. Across from DARPA, we have a bus stop. If somebody is sitting at that bus stop for a long period of time, are they just waiting for somebody who's late, who should have arrived on the bus? Or are they trying to observe the changing guard patterns that we have in the front of the building? Well, in order to determine what the difference between those two might be, would be just to have a vehicle move to obstruct their line of view. If that person stays put, less likely they're a spotter. If instead they move to reestablish line of sight, more likely that they have other plans. It's not a one-to-one, but it does provide more direct. It gives us direct evidence instead of circumstantial evidence that this person means something other than just waiting for the bus. So because we're interacting with civilian populations, immediately legal, moral, ethical considerations have to be at the forefront. So in order to tackle this problem, we decided to take a different approach. We traditionally use in DARPA something called LC panels, which are panels of experts that consider a technology and what are the worst things that can happen, so we can put guardrails on the program and make sure that we're considering them appropriately and not inadvertently getting into an area that everybody's uncomfortable with. We decided to take that model up a level, and we came up with what we call the Legal, Moral, Ethical Working Group. This is a true team of rivals. I won't share their names. That's part of their participation. They can share who they are if they wish to, but I won't offer up their names. But we didn't just ask bobbleheads to be part of this process. We wanted people who truly have issues with using force downrange in an autonomous system using kinetics, release of kinetic weapons, as well as people who have a lot of optimism about what AI can do in this space. And we fed them by integrating them with the engineering teams and having them work directly with the engineers developing this process, developing these capabilities, look at every major engineering architecture decision along the way and question what are the implications that came from that. Through that, we had a series of interactions. And again, this is an active interaction between our engineers on one side and the working group on the other. This is essentially the beginning the phase one process looked like. Moving into phase two of the project, once we had these prototype systems, we took it a step farther and we said, okay, let's build, because we like data and we don't just want to talk about what ifs. Let's build our base case system and let's build our LME system, our legal, moral, ethical system. And then let's compare the two and see what the delta is between the two of them. And that's where things got really exciting. So I'll move on then to essentially the punchline of, it's funny because as I get into this, you'll hear me be very optimistic. But in reality, I'm very pessimistic about both current AI capabilities, but also about human capabilities downrange, right? So in order to understand the true opportunity space here, I think it's also important to understand, and this is something else that Dr. Jetty brought up that I thought was right on, is that we really do have to compare it to what a human in the same situation would do. We need the right frame of comparison. And so for the URSA program, for every case that we studied, when we're testing this in live urban environments with role players, real people, they don't know what's going on. They sign consent forms and they've agreed to be part of testing, of course, but they're not wise to the scenarios that we're putting before them. We compare an operator using the URSA system to The current state of practice force protection system, somebody essentially looking through the same sensors without any of the reason or perception interaction capability at the same time. We compare head to head how those two systems perform. And so that's, again, the framework. What we found, does AI do ethical AI systems necessarily have to be, or does AI necessarily have to have a reduced capacity for ethical operation? The answer there is no. If you think about a human downrange who is dealing with stress in particular, and this is what some of my doctoral work out, was how do cognition systems break down in the face of stress, and it's not pretty. Our perception is limited, and our memory is pretty rotten, especially when we're in those stressed environments. If you look at the AI principles, the one being one of the primary ones, well, they're all primary, traceability, the capacity for an AI-enabled system that has traceability of all the data that went into deciding whether somebody is a person of interest versus somebody on the ground saying, I think that's the same person I saw on that other block 15 minutes ago. I think that's the same person, and they exhibited threatening behavior then. So I think I see them doing something I don't agree with now as well. And that together should give me justification. An AI system has all of that data. You should be able to create a dossier that you can pick up on any person that you're monitoring, and you can have a much a greater capacity for transparency than you would in just relying on human cognition systems alone. The second is constraint. Does an ethical AI system necessarily have to be a constrained version of the whole system? No, we found is not necessarily the case. And this goes back to who is it that's operating the system? The mission commander, in our case, an operator, they are inherently virtuous. When we were building our two versions of the systems and testing them against one another, we found that our test mission commanders in all cases said, that feature that you created for your LME version, I want that in the base version. That's not an accessory. That's something I want all the time. And so here I really think our metrics have to be adjusted to make this appropriate. Constraint, if you're talking just in timelines, yes, you might have a slower system. Are we constrained or when we're talking about what the warfighter wants the tool to operate as? Then if we look at it from that lens, it doesn't necessarily need to be a constrained version of the system. Contribution. I mentioned earlier how the working group works so closely with the engineers. The same way that we view the warfighters who are a product of our society, of our legal system, of our ethical and moral system as inherently virtuous, the same is true of our engineers. The people who are building these systems want to know that they're involved in creating systems that are extending their own virtue. And as such, this should not be a process left to the ethicist. Rather, it has to go all the way down to the people who are making even the lowest level coding decisions. And then finally, time. We thought that this process of involving the working group in all of our work would inherently slow it down. It didn't. On the contrary, by getting the engineers to think bigger about how their low-level decisions were going to have system-level implications, it helped them get ahead of technical challenges that they were going to face at some time down the road. They were able to get ahead of those problems rather than having to backtrack them. So I'm very optimistic, despite my pessimism and overall skepticism about reliability of both AI systems and cognition systems alone, working independently of one another. But this concrete approach to DevEthOps, I think, has given us a path for how to handle this very difficult problem. I'm not diminishing the problem for how difficult it is. It's pretty challenging, but at least gives us, I think, a path forward, something to start with. Now, this is just one example, of course. We didn't take on all of the AI principles. We didn't take on the complete list of moral, ethical, and legal considerations one could possibly consider. So we have some follow-on work in what we're calling virtuous AI study, where we're trying to address the completeness. How do you then take it a step from just, this is how you can do it, to how do you do it completely? How do you ensure responsible human oversight of these systems in a way that would be compliant with, say, acquisition principles? So I'll stop there and happy to answer any questions, and looking forward to Mary's talk.
Great, thanks so much. I think we'll hold the questions. I don't see any questions on your talk yet in the chat, so let's hold the questions and go over to Mary. Mary, over to you.
Hi. Well, thank you. That was great talk, Mark. This is an honor to be here, but I have to be totally transparent. I'm filling in for a colleague, Dr. Beverly Thompson, who could not be here today because of family emergency. So I wish her and her family well. If you ever get a chance to hear Beverly speak, I highly recommend that you do that because she's very thought-provoking. But I am excited today to talk about this topic. I have done a lot of work with warfighters for the last 8 years in terms of assisted and automated AI. So I've got a few ideas and thoughts of my own that I'm excited to share. I do want to put out another disclaimer. I've never really formally studied ethics or virtues. I've had conversations with folks about it, but the few presentations I was able to see today really opened my eyes, very, very deep and thoughtful. So please forgive me if I misuse the semantics. So anyway, I'm going to talk about work that I've done, like I said, with the warfighter over the last 8 years. You heard Ron Keesing speak this morning. Leidos does just a ton of work around AI. His group in particular reaches out across the country, the company, and we do AI in our health, civil, intelligence, and defense. So I'm not going to have time to cover all that today, but if you're interested, go to our website, our Leidos website, and look at all the good work we're doing around AI. So like I said, I've been working in this area for about 8 years, mostly with the Air Force and the Army, for the research labs and DARPA. And what I've been focusing on lately at the Air Force is something, well, you mentioned in my introduction, is what we call MUM-T, manned, unmanned teaming. And so what this typically means is how do we build teams that have humans and have non-humans in them. So we looked at research on all of human teams and what made very effective human teams, and we looked at the characteristics there. So we are systematically trying to apply those characteristics in MUM-T situations. And the MUM-T situation I'm talking about is an armed fighter pilot flying with an autonomous vehicle. Now, not a drone, an autonomous vehicle that has been pre-programmed for the mission to do what the mission is there for, and then return safely. Now, I also need to say, as has been pointed out a couple of times today, that there are no fully autonomous systems, combat systems in the United States today. So yes, they are prototypes that we've flown, and they are, and still are when they're envisioned, they will have a human pilot in the C2. Folks on the ground will be able to intervene and change the trajectory or change the mission based on information that we receive after mission planning. So all of those little caveats. So the autonomous vehicles today are very controlled and very constrained by the human operator. So anyway, I want to share some of my observations over the last 8 years and some challenges. And these observations are very loosely organized around the Department of Defense ethical principles for artificial intelligence. And I'm sure Dr. Chapa can talk way more about that than I can. And I apologize for looking down on my notes so much, but I have been scribbling notes all over my notes about comments that people have made this afternoon. So it's kind of messy. So the first one I want to talk about is traceability. In my field, we talk about transparency and explainability. And why is that important to the warfighter? Because basically that is the way they determine their trust. And we don't talk about just blind trust. We talk about calibrated trust. And somebody earlier today mentioned how dangerous it was if we overtrust or undertrust. And in these situations, it truly is dangerous. Somebody could get hurt. So what we talk about is calibrated threats, which basically means we have to build within the operational end user the ability to determine when to trust and rely on the AI and when not to. And that's very important. We all do it. We do it with our GPS. If we have ways, it says get off, and you go, no, I know a sneak road, I'm going that way. I don't trust you in this situation. I was in a very rural part of North Carolina after a hurricane one time, and I was trying to take a road that wasn't on the detour. Well, I quickly found out it was blocked by water. But so Waze was not very effective because there weren't a lot of crowdsourcing in the rural part of North Carolina. So there weren't people there saying, hey, this road's closed. But I know where I live in Northern Virginia, Waze is very accurate because there are tons of crowdsourced folks who put in the latest, recs and stuff like that. So I know when I've got a calibrated trust for Waze. I know when to question it and when to use it. And our warfighters need that very same thing. Also, as Dr. Bartlett said earlier, we're very interested in stress and how stress impacts workload or impacts the ability of the human to react. So we're looking at how does workload increase or decrease as a result of the AI, and there's a happy balance there too. You don't want to be overly stressed because you're working too much, but you don't want to be under stressed to the point that you get bored and you start to focus on other things. So we're looking at that balance. Let me see. One of the ways that we help build a firm calibration of trust in the operational end user, this was brought up earlier today, is through training and also including the operational end user in the whole life cycle of the research and development of the system. And we do that. Before we start building stuff to supplement the system, we actually go out to the operational end users. And I keep saying that because sometimes we use end users who used to sit in that seat a couple of years ago and think they know what it's like to sit in that seat now, but they might not quite get it right. So we do go out to those operational end users and we say, hey, this is what we're trying to build. And we think it fits in your mission this way. What do you think? And what actually do you need it to do? What do you need it to look like? What kind of information do you need? So we get a thorough understanding of what their needs are before we build it. And then as we're building it, we use operational end users again, or recently separated end users on the design team. So that was a question somebody said today. Why don't we do that? Well, we actually do. We also include the operational end user in our modeling and simulation events, our demonstrations, and our field tests. So they are a part of the development. We're constantly getting feedback from them on how to improve the system and how to make the system fit the human. So I often joke with people when they talk about using the operational end user, and I've used it several times, so I'm just as guilty, because many of the systems that we're building today, I always say the folks that are actually going to be using these systems are in middle school right now. So they are innately different than the operational end users that we look at today. They have been using technology, their phones for their whole life, as opposed to some of the folks that we call operational end users now. So we always have to be understanding of what the end user is going to be like as well further on down the line. So another thing that someone mentioned today that I found very interesting is in a program that I'm working on for the Air Force Research Lab, we're not just looking at the technology and how the human is integrated into the technology. Somebody had the forethought to say, you know what, if we have an autonomous vehicle that is in a MUMT situation, it's not just the mission. They have to somehow participate in the pre-mission planning. So how do we bring an autonomous partner into the planning, and then not just the mission, but then the debrief process? And we've been looking really closely at the debrief process because right now the machine is kind of a prototype. Or it is a prototype. And so we have to get the data out. We have to physically remove it from the hard drive, take it to some analysts. They pull it out, they analyze the data, and then they can give us information about what the machine was doing at the time it made decisions. Now, this is too long because typically debriefs follow immediately following a mission. And it is that someone was saying that explainability is not something that naturally occurs in human relationships. But in this case, it really does, because I guess you can validate that. But the pilots and the crew sit around and they ask each other, they review the mission, ask each other, what were you thinking when you did this? Can you tell me why you did this here? And so now the AI can't participate in that debrief because it takes too long to get the data down. And when we do, it's ones and zeros. And so it has to be interpretable to the human immediately following mission planning. But immediately following the mission, but we're working on that. So it is a lot to do, but it is something that we are working on. I have to say that trust really became clear to me. The need for trust came clear to me about 8 years ago on a project that I was working on for at DoD, where engineers had built this system where they fused data together, and they had it was brilliant, really, and it took a lot of different companies and a lot of different engineers working separately and together to build this system. Well, it came time to test the system, and excuse me, they brought in some active duty geo ents to help in the field test, and so it was a very crowded room. We had lots of retired generals and active duty generals and all kinds of folks there to watch the system take off. Well, as soon as the system took off, the geoants sat down, they looked, and they're like, the puzzled look coming to their face, and they go, I don't know what this is. And they said, I can't use this. I use dots. These are dashes. What do these dashes mean? And so it was a little bit embarrassing, but they had enough professional pride to say, hey, I was trained this way, and I feel confident that when I make a recommendation using these data, that my recommendation, I have faith in it. And so they did not trust that system, so they didn't use it. So back to the drawing board, the engineers went, but this time with some of the operational end users in the same room, and they worked together to build a system that the end user could trust, and they could end up drilling down for data, but which they should have done in the first place. So that's a pretty good example, I think, of how you can build a beautiful system, but if the end user is too scared to use it, then you wasted your time. Sorry. The next one I want to talk about is governable, which means to detect and avoid unintended consequences. And I'm really excited to share this because there has been discussion today about reducing lethality or only using the right amount for the mission, and how do we reduce civilian casualties. And so there's a program that I'm working on now with a huge team at the Air Force Research Lab, where we're building an interface so that the machine can talk to the mission commander, basically. And the machine is there's a tool called the Advanced Decision-Making and Reasoning System. And what this system does is it calculates collateral damage estimates. And so the UAVs can go fly in, take the pre-calculation, what we think we know, the UAV will fly into the zone, get more data from the sensors, and then sometimes they'll say, nope, can't do it. There's school children playing bird, or they will also calculate, because they carry several different weapons, which weapon at which angle at what time could be used just to eliminate that one particular target and not affect so much people or buildings, for that matter, who are around that target. So a way for the system to communicate to humans and yet also give us more feedback, so that we know when we decide not to hit a target, we can make a more ethical decision in real time. So let's see. The next one is, also that it gives the human ability still to disengage that UAV from dropping any sort of weapon. So if a human at the end goes, no, don't do that, it will stop. So the next one is reliable. And I think someone this morning mentioned reliability. And so the systems, I think, and I already mentioned it too, the systems that we are working on are tested from conception all the way through deployment. So we test it in modeling and simulation, we test in field studies, we test in demos. So throughout the entire life cycle, it's tested so that we can be more confident that this system is going to do what it's been programmed to do. And we, again, use the operational end users in those testing because they gain confidence that the system is reliable. Let's see. All right, the next part, I just want to talk about a few of the challenges. There's a lot of challenges, and people have mentioned the challenges throughout the afternoon and probably this morning too. But the challenges that I see implementing AI technology at the ground troops level is how do we define ethical technology? Just listening today, there's no clear-cut list. Everybody else, I read a little bit in preparation for this, and every list had different virtues or different ethics in it. So, I think first of all, we need to agree on what we determine are ethical behaviors for AI, and so that's the challenge. But I think we also need to test our systems based on those ethical definitions. So are the systems, as we're testing them from very beginning, from the modeling and sim all the way to field test, we need to just test their ethical behaviors as well. So not only test, can it fly, does it follow directions, can it land on its own, that sort of thing, but give it test cards that really question its ability to make ethical choices. Another thought along that same line is typically when you build a system like this, you have tens of, maybe even 100 engineers who build pieces of code that goes into the final system. And so you have to be very careful. I believe that all of the coders agree and understand what sort of ethical decisions mean and how they are, they're baked into the AI system. So that we need to pay attention to that too. And then once we agree on the definitions, I think we need to understand how we program the AI to think and to reason in situations that either require ethical considerations or unique situations that they've never encountered before. So how do they take what they know about, I'll talk about it in a minute, about ethics and generalize it to other areas, but then also to transfer it to areas where they've never encountered that before. So some people have talked about that today too, and I do see that as a real problem. I talk about know and act. So I think that the ethics needs to be, and someone else used this word, and it was actually in my notes, baked in from the beginning. So it has to be in the code from the beginning. We can't build the code and then, okay, let's jam this stuff in at the end too. It needs to be baked in and tested throughout the entire process of the development. So how do we train the AI? Just out of general, I was thinking, wow, how do we train humans to be ethical? It takes a lifetime. And we train them by teaching them, but there's no real curriculum that we use in school so that by the time someone graduates from the 12th grade, we can say, yes, you're ethical human being. It's something that people sometimes don't ever learn. And it's sometimes people do learn, but they learn it by observations. I'll date myself, but when I used to watch cartoons, there's always a goal or a lesson or a moral at the end. And so that was a way of learning, what was appropriate and what wasn't. Our families certainly contributed to that, and people that we admire, we watched, and maybe we learned some ethical behavior from them. So that's going to be hard to package, I think, and teach an artificial intelligence. So another is that I believe that the AI has to be developed with the same rules that the human teammates are bound by. So, and both static and dynamic rules, such as, let's see, the laws of armed combat, for instance, and then the rules of engagement, which are not as static, and air tasking orders, I think, are particularly important. And some of these those are just decided as a mission. So the permanent long-term rules probably need to be hard baked in, but then there needs to be a way during mission planning to alter the software so that the AI understands the rules of engagements for this particular battle or mission and the air tasking order. So that needs to be implemented as we're developing the AI. Finally, I hope I hurt anybody's feelings, but I think this current, I'm an engineer, so trust me, line of thinking has got to stop. So engineers will say, okay, I know how to do this. I mean, they're very confident people, and they go and they build, and then they let the human systems person come in and say, okay, how can I mold the human to fit the system, which to me is exactly backwards. But after today and after studying, I think, wow, we probably need, I've been fighting for human system integration the whole time. Now I'm going to fight for military ethics SMEs to also be involved in the development of AI. So we do have people that know what they're talking about, and I think that we could include them in the conversation. My computer just went blank, so I hope you can still hear me. So in conclusion, we're not at the stage of fully autonomous AI today, but we'll eventually get there. There's a lot of work to do, but I believe the use of AI technologies in the military will only enhance ethical behavior. AI has the capability to very quickly collect, analyze more data from a variety of sensors to arrive at more effective courses of action that will reduce human error and consequently collateral damage and human death. And that's what I have to say. I hope you can hear me because I've got to turn my computer back on. So.
Yes, we can still hear you and see you. Thank you for proceeding, even though you lost your monitor.
You're welcome.
Excellent. Well, what I'd like to do over the next couple minutes is kind of pull a few threads that I think I heard in both talks, and then I'll give you both an opportunity to respond if you'd like to, and then if not, we'll go right to questions from attendees. So to start with something that you mentioned, Barla, right at the beginning, I'm struck by the fact that when you mentioned the bus stop case outside of the office building, if we were to try to figure out how to foil that person's attempt to read the patterns of life at the building, it takes a certain amount of empathy, right? I'm naturally asking myself, well, if I were sitting at the bus stop and I were trying to document patterns of life, what would I need? Well, I would need a good line of sight, which means that I could foil that attempt by disrupting the line of sight. And I just wonder, as increasingly move toward autonomous systems and enabled systems, and maybe especially machine learning systems, we're going to start to encounter systems that really don't think anything like the way that we do. And so in a traditional context where I might be able to empathize with an adversary to try to determine not just what they're trying to do, but how to foil what they're trying to do I lose that ability as the adversary starts to develop autonomous systems or AI tools? And so really it's a broad question. I don't know if you have a specific answer, but something to think about over the next several minutes. And then Mary, you talked a lot about this calibrated trust, which I think is a really good way to think about it. There was a time that the forthcoming DoD responsible AI strategy was going to be built around this idea that what we're trying to do in DoD responsible AI is increase trust. And as you point out, several people pushed back against that and said, well, no, we don't want to increase trust if the systems aren't trustworthy, right? We actually want to generate just the right amount of trust. And I think that's crucial as we go forward. But I don't think it's going to be easy. We've talked plenty today about, the difference between what we might think of as, moral philosophy, philosophical ethics, competing conceptions of the good, and how that's really not the same thing as a compliance culture where we just have a checklist, and as long as we've checked everything off the checklist, then we're good to go. And that strikes me as a hurdle specifically in the DoD that we're really going to have to overcome. It's easy to get to this kind of compliance idea that as long as I have a checklist, I'm good. Speaking as a person who used to fly airplanes, every airplane I was ever trained on, they issued me a big fat book. And in that book were dozens or hundreds of notes, warnings, and cautions. And my job was to memorize those so that I could interpret the messages in the cockpit, right? If I get a certain series of lights in the cockpit, I'm able to figure out what that means. What is the system trying to tell me? And I think that at some point, we're going to have to crack the code on what is the notes, warnings, and cautions equivalent for AI-enabled systems. Right? What do I need to train an operator to look for to recognize faults in the system? And this operator is not a data scientist, and they might not know how to code in Python, right? But they need to understand enough about the technology that's operating under the hood, as it were, to be able to recognize these faults. And I think for us in the DoD, that's probably the next big workforce development hurdle, is to get to that level of fidelity on understanding the faults in the system. I want to mention two cases that I think are helpful they're in the literature, but they're also out there in industry, and how that might pertain to this DoD culture that I'm referring to. So the first is, there's a well-known Amazon case in 2015. They tried to use a machine learning system to automate their hiring processes. So the idea is they had 10 years of historical data on hiring practice. That was enough data to train their model. And so very shortly after they started this process, they realized that their model was biased against women and toward men. And it was a traceable system or an explainable system. So they were able to kind of do the autopsy and figure out why. And one of the things they learned is that the system was penalizing the possessive noun women's. So if a resume said women's college or women's engineering organization or something like that, it actually penalized it because it recognized over that 10-year history that men were hired more often than women. The tech industry is kind of notorious for that. So we shouldn't have been surprised by the outcome, right? And I mention all this to say that when I talk to military people about this, I get one of several responses. Response is when I tell the story and say, this is an ethical problem, right? One response is to say, yes, that's an ethical problem, because if an Air Force person used that kind of system for our HR practices, they'd get fired. Okay, that's compliance culture, right? That's not necessarily ethics, but it's close. We're getting there. And then my attitude as the moral philosophy person is to say, well, this is just an unjust distribution of goods and harms, right? People experienced a harm that they did not deserve. It was an unjust distribution of harms. That's bad. There's a moral cost here that needs to be rectified. But when I talk to other military leaders, one other response I get is, if you use that system, you get the wrong answer, right? What we were trying to do was hire the best person, and now we're not getting the best person. And I just wonder what you think about this idea that a lot of the ethics cases for AI in the domestic context have to do with, disenfranchised groups, race, gender, minorities. And when we think about, when I think about combat applications in a fight against a peer adversary, I have a hard time thinking about how questions about gender and race would be applicable. But we still know that there's going to be challenges with data bias or insufficient data or algorithmic drift or all those other things that we hear about in the domestic context. So I'm wondering what you think about the idea that when we talk about the combat environment, it might be the case that our ethical concerns and our operational concerns start to kind of overlap a bit. There are going to be some ethical concerns that aren't operational, but that set gets narrower and narrower. And actually, the people who are trying to get us to the right answer, the people developing the technology, and the ethics folks like me who are trying to get us to avoid making moral mistakes, we're actually on the same team here, and we should all be driving toward AI technologies that are getting us better answers faster and that are avoiding both ethical and operational failures. So those are just a few thoughts. You can take them in any direction you like. But Barlow, we'll start with you if that's okay.
Yeah, no, on your last point, I agree wholeheartedly. This is some of what we're finding on URSA, is that oftentimes the most technically proficient solution is also the one in line with LME principles. And there's a lot of reasons to believe that's so, but I think that's really the positive outcome of what we're seeing. And that's not unrelated to your first question about the empathy piece for the bus stop example. And I think I have two particular comments to that, one very specific to this, and then one more general. You're right. And that it maybe, I would say, is maybe we, by including AI, we remove the opportunity to empathize with people. If you're looking at numbers as opposed to faces, as opposed to people working in and around their environment, are you more likely to depersonalize those people that you're trying to determine what is this person after? And the answer is probably yes. Like, there's lots of good evidence from the laboratory that the more you can distance yourself from another human, the more easy it is to do bad things to them. Like, that's well established in the literature. But I think where this comes down to is the HMI. We have not really spent a whole lot of time determining, to your example about ICAUS and what alerts you were given, we haven't spent a lot of time thinking about what information you need to transfer between the system and the human in order to ensure responsible human oversight. And I agree entirely that it is not a data scientist that is going to be doing this, and that we have to, that doesn't mean that we're looking at writing the human out of the system. We're not trying to diminish that human's capacity. Rather, we want to focus that human on what humans do best. And I really feel like you were setting me up to plug my other program, Edge, which is all about HMI design for AI-enabled systems. And it is determining, I want to get past the workload side of this conversation, because it has been so dominated by these people that, these poor operators are going to get so overwhelmed. They're not, they have too much information. They're not going to be able to decide. And while that's true, while we have limited bandwidth, by focusing on cognitive overload, the easiest solution for that is just to stop transmitting information, just limit information transfer. But of course, you're then end up with a human that is barely on the loop and doesn't have enough situational awareness to come in and make the kind of decisions that you want them to make. So in the EDGE program, we're looking at this question from the standpoint of adaptability. We know AI-enabled systems currently are very brittle. My definition, my working definition of what it means to have responsible AI oversight of AI-enabled systems is how well can that operator adapt that system in the face of off-nominal failures, whether it's a fault within the system or whether it's a context that the system has not yet encountered yet. And if the operator can do that, if they can adapt the system and not just go home, essentially, then that is, it's akin to Sully Sullenberger landing his plane on the Hudson River. That's not the outcome that he intended to have that day, but it was about as close to optimal as you can get given the circumstances that he was handed. So how much does the operator need to know in order to then? On that point, and going back to not just dealing with faults, but going one step farther, what is the role we want the human to? Is it just oversight? Is it just to stop that? Or is it to provide this discriminatory power to say, what should we be doing? The intent piece, so the interpretation of commander's intent, not just commander's orders. In that line, if you look at the way interfaces, especially on platforms that have limited screen real estate, the drive is to make very simple icons, very simple icons or indicators and warnings. The problem is that inherently limits how much information the operator has to deal with, right? So if you instead have, a number of pilots that I've spoken to, when they see a red icon show up of an enemy entity, said, well, if it's red, it's dead. Great. I have no doubt that a highly trained pilot can neutralize when they see a red, an entity that is designated as red on their interface. But the problem is that if that's what we want the human to do, there's no reason we shouldn't automate that, because we're not giving that operator enough information to question what information went into designating that icon red, what are the uncertainty parameters around it, and what is the confidence interval that, the competency and estimate that the perception system and the reasoning system has to say with confidence this is what we think it is. One of our strengths as a military compared to authoritarian nations is that we like to push decision-making as far down and forward as possible to enable that kind of frontline adaptability. But unless we build our HMI systems to elevate the kinds of information that we want the human to be reasoning on, then we're not going to get that kind of performance. And so I'm looking at that very critically on the EDGE program. And I think this applies to your empathy question as well. If we want the human to have that sense of empathy, of that, to get away from mirror imaging assumptions, and this is, this gets into a whole nother challenge when you're talking about different cultures, we need to elevate the right information to provide that perspective and to provide the opportunity to empathize with the people in and around the ground who, most of them, the vast majority, are not threats. They're just trying to, pick up their kids from school or, work within the constraints of their day. And that's the kind of thing that we want to enable, not diminish. So a long answer, but I think it encompassed all the questions you asked.
That's great. Thank you. I'm suffering from my own computer troubles here. I was able to dial in with my phone and I caught almost all of your answer. But thank you very much for hanging with me despite the challenges. Mary, over to you.
So you talked about how difficult it is to build trust, to calibrate trust. And one of the things I did not mention that we are doing currently, I think it'd be okay, but you may know Dr. Joe Lyons. He is a pretty well-known trust researcher at AFRL. So we're working with Joe and lots of other folks at AFRL to implement trust studies within our environment on base. And so the first one that we're looking at is kind of interesting. So we're trying to figure out what is it about an HMI or a situation or a system that either builds appropriate trust or doesn't. The first one we're going to look at is called the pull-down effect. And what we found in other research, not so much in military though, is that when one component of a system fails, then we have a tendency, it pulls the rest of the system down. If I don't trust this one light, then I have questions about the entire system. So we are beginning our studies on, okay, how does the pull down effect have impact on the HMIs that we build and the systems that we're building? So we are really looking into trust right now. The interesting thing is every Friday morning I have a meeting with AFRL, our HSI folks, and Joe is there, and a lot of really very experienced folks. And so this last Friday, I said, hey, I've been asked to fill in for a colleague, and the topic is ethical AI in the military. I said, do you all have any articles, anything you can share? I mean, it was crickets. Nobody said a word. I'm like, oh, this is bad. And then Joe said, well, there's the Department of Defense ethical AI paper. So I did look at that. But so it's not something that I think is really ethics, and we're looking at the pieces and not the bigger piece as far as ethics goes. But we are looking at trust. And then I wanted to mention too that sometimes it's not the system that we have to calibrate our trust. We have to know sometimes when other systems fail. So there are situations which I'm sure you can elaborate on where radars are not as reliable as we think it should be. So in those situations too, not just the AI, but we know that the data the AI is getting could be flawed also. So that it expands that trust onto that. Something the other thing about HMI, and Bart started talking about this, but one of the things that we're finding is how do we scale up? That's a huge question. Right now, if you have one manned pilot with one unmanned vehicle, that's kind of easy. Build an HMI and people constantly know who's doing what. But how you do that if you have 300 unmanned vehicles and a manned vehicle? So we're struggling with HMI and giving what information needs to be there when no noise, so that the pilots can make better choices. So that's a real issue. I think that was it. Oh, I did want to say one thing that, we, someone mentioned culture. I think it may have been Bart. And so culture is part of what probably needs to be baked into some of the AI, because they were saying how, we can use ethics if we understand the culture. But I think sometimes traditionally, our adversaries have used our ethical principles against us. So, they will put children out in front of bomb factories, or they will, that sort of thing. So, because if they think, oh, Americans are not going to target any building that has children in front of it, or women, et cetera, et cetera. So anyhow, that's my 2 cents.
That's great. Thank you both for the insightful comments. There's a question in the chat for Bart. It says, thanks for sharing the research. How did the LME considerations come into play in the field test that you did?
Sure. We picked a number of different cases. Probably the most tangible, easiest among them was, do we have the ability to designate no-go areas that we would not allow the systems to interact either with a location, because maybe it was a place of worship, or with an entity. You mentioned children, Mary, just a second ago. If we designate somebody, if you can detect somebody is likely a child, we don't want to interact with that person, even if our engagements are very non-threatening, like a needs survey. What are the needs? If you're looking at a stability ops type situation, you want to ask if people need water or medicine. Even with that, we don't necessarily want to engage with children. We also looked seriously at how do you calculate harm, not just harm of a single engagement, but of repeated engagements over time. What does that look like to try to calculate harm? How do you consider the relative nature of certain kinds of interactions? And how do you benchmark that against what we have our intentions of what we think is a non-harmful, non-escalatory, non-threatening engagement, but we have to benchmark that against how it's being interpreted on the other side. So we had a lot of in-depth interactions with our role players to say, was it clear what we were asking? Did you feel like it was disrupting your daily life? If we are constantly asking people to show their ID, for instance, a shop owner is going to get really irritated, even if that person was neutral or friendly to U.S. forces. If we're disrupting their ability to handle daily business, they're not going to like us after a while. So that's a second way. And then the third, and potentially some of the most interesting ways, because it connects all the way down, up and down the engineering chain, is looking at agency transfer. So we did test and enable some of the vehicles to initiate their own engagement with some of the role players. Very limited set of engagements they were permitted to engage on their own, and they were very generalized capabilities or generalized actions, like a needs survey that I described earlier. But looking at what point in the decision tree you can authorize that agency transfer, that that specific technical capability has threads all the way back to very early architecting decisions. And so that one was one of the more challenging ones, but it's also coming up with some really fruitful insights and some really fruitful capability, additional capabilities where you can essentially have one person doing 3 or 4 things at once, but all with confidence that he's not exceeding any threshold of harm, as an example. So those are 3 examples of the kinds of specific LME considerations we brought into the environment.
Yeah, that's great. Just a quick follow-up to that, if you would. You mentioned that the LME-enabled system was more effective than the base system. In what way was that the case, or how could you tell?
It really came from self-report of our mission commanders. These are former ops folks, recently former operational folks. So, to Mary's point earlier, that our the people that are going to be actually operating these systems are, I would even say, go farther than middle school. I'd say they're in diapers. These folks have seen these exact kind of infantry situations downrange, and they said, for the job I am doing, for identifying threats to potentially engage or prevent that threat, we're not using any sort of kinetics on the program. Before, say, a convoy comes through the area, in order to do my job, these are the tools I want. And when they saw things like, I don't want to engage with children, I want agency transfer controller that I have a really clear understanding of what it's going to do. They didn't want false positives. That's really what it came down to. Like it really comes back to the fact that the warfighter inherently wants to be virtuous. And I speak with the vast majority. Obviously, there are exceptions, and it should be and rightly are taking, our court-martial system and our military legal system deals with that when it is appropriate. But the vast majority of it, and what we train to, is very ethical. And in order to extend that capability, they see it as part of their job. False positives in many cases can be as disastrous as false negatives. So that it came from that perspective.
Great, thank you. Ron Keesing, you have a hand up. Feel free to come up, video or video and audio.
Sorry, that's purely unintentional. Sorry about that.
Oh, no problem at all.
Just waving hello. Hey, Ron.
Great. Yeah, as we, one of the things I noticed just from my perspective, at the Department of the Air Force is about 600,000 people. So when we talk about scaling best practices in ethical AI, that's a very real challenge for me in my job. And one of the things I've noticed from DARPA and from other places also, that I would say are smaller organizations and have a higher ratio of sort of technical talent to non-technical talent than we do in the Department of the Air Force, is that this ability to red team projects, right? To try to anticipate what the ethical challenges will be. That seems like a fantastic way to go. I wonder in my own organization if we have the capacity to do that, right? How do I scale that if I know that I don't have the subject matter expertise that I would need to pull that off at the kind of individual unit level, or at all of the places where AI tools are being developed? Do you have any? Have you noticed any kind of best practices that have come out of the process where you might be able to kind of structure some of what that team is doing to be able to provide guidance to others, or do you need it to be organic, where every time this team is coming to a new proposal, new project, new program, or whatever, they have to go through that organic process in order to get the results they need?
Sorry, is that for me or for Mary, or?
I'm sorry, Bart, that was for you.
Okay. So I'm a true scientist. I'll say that is probably an empirical question of whether we can repeat the magic. But I think that it's a little bit of both, right? I think that we're already working at a level where, the number of conversations that are going on about this topic, the amount of concern in society about this topic is a good indicator that as concerned citizens, these are things that we want to adhere to. So you're already starting with that baseline capability in people's hearts and minds. As far as whether we can package it, we are working really hard to gather first principles for how do we do this, not just in let's do a proof of principle, which is what we've done on URSA, but then expand it and say, how can we not just do this for more broadly across programs? And you'll see that in some of the more recent BAAs that have come out of DARPA. One in particular called In the Moment that my colleague Matt Turek has just released has a component where they want to look at the legal, moral, ethical pieces. And a lot of that came from inspiration from what we did on Ursa. I won't claim credit for that connection, but indeed he knows of the model, saw it, and went so far as to make it an entire TA on the program. So a little bit of it is a thought contagion. We'll see if it's successful in every condition, in every case. But I do think that the model of having this active participating capability, some other team that's not necessarily a threat down select over the course of a DARPA program, who is working with the engineers, trying to improve the overall product, does have, in working on concrete rather than philosophical hypotheticals, really seems to be where the magic is in our experience. And so I think we're going to get evidence pretty soon about whether it does extend. And then that's, again, just from a program by program case. But from the question of, if you think about it from an acquisitions perspective, how on earth, if you don't have SMEs in the acquisitions community necessarily who can stress test all this, how do you create a model that allows you to more quickly create assurance cases for these capabilities? Because we know that the exhaustive checklist-based systems that we rely on for deterministic systems are just intractable for non-deterministic systems. Whether they're AI enabled or just highly complex, it just doesn't work. The math doesn't add up. We will bankrupt these companies who produce these technologies if we ask them to do it that way. Part of the virtuous AI work that we're doing is looking at a different model. Can you do something like a team of rivals where you get the engineers to red team each other's stuff? That's nascent right now as a concept, but we're thinking actively about it because it's one thing to do it once. It's another thing to do it completely and to have a complete and confidence that your end solution is more complete than, you will never have full completeness, but it is more complete than what you get in a more exhaustive checklist-based opportunity or approach.
Yeah, that's great. And I think that dovetails, Mary, with what you were saying about continuous testing across the life cycle of an AI-enabled system, right? That it needs to be the case not only that we test for specific operational performance characteristics, but maybe that we test for compliance with the ethical principles, for example. I recognize that that's a non-trivial challenge, right? Trying to come up with measurable metrics against which to measure things like governability or reliability. Do you have any insights there in what you've seen in testing some of these systems, maybe specifically in the man-on-man teaming world, where we can start to get a sense for what standard we would hold a product to in order to meet those ethical standards that DoD has set out?
So that's a pretty tall order, and it's kind of tough. We've struggled for how do we measure trust. I mean, nobody can really agree that this is how we measure trust. So. And that's a slippery kind of thing to define. I think that ethics would fall in that same line where, are you testing ethics or are you testing, something else? But I could see it being done, especially in a modeling and simulation environment where you could do some test cards that would, make the human, or at this point in the development, the human really controls most of what the autonomous vehicle does. But you could have, I guess you could throw in some tests that would, that you would hope that the AI would respond and say, no, I can't do that because, and then what their thinking is. So, and then maybe certainly in the other program that I was talking about, where we're building the interface to help calculate collateral damage. So that I think would be very interesting and probably the ripe area for implementing some sort of ethics question to throw in or activity. So that'd be my recommendation. That's a little bit more concrete right now than the other stuff that we're doing. So I think that might work.
Okay, great. And back to you, Mary. So you talked about the scenario in which an unmanned system might be the thing that determines that a track is an adversary or a hostile track, and then it might pass that information to the traditionally piloted aircraft. What kind of transparency would that system have to provide that pilot so the pilot can be confident in what it's receiving as a hostile track. Have you seen any best practices in the level of transparency that would be appropriate for that manned-unmanned teaming application?
So, yeah, transparency, and this I learned from Joe Lyons years ago. Transparency has to be trained. So you'd have to have multiple training events where that pilot has gotten similar communications from similar autonomous vehicles, and the pilot begins to trust that the UAV can make the right decision. So trust and transparency go together, but they have to be taught, and it's experience over time. So.
Yeah, great. I'll raise one last question here that both of you can take a stab at. But again, when we think about ethical challenges and then we think about operational challenges, one of the cases that comes to mind is the 2018 Uber car crash case. There was an autonomous vehicle that had a fatality crash in Tempe, Arizona. Lots of things went wrong, but one way to characterize what went wrong is that the training data was insufficient to replicate the real world. It had been trained to recognize a bicyclist. It had been trained to recognize a pedestrian, but it had not been trained to recognize a pedestrian walking a bicycle. So that, among other things, ended up in this fatality crash. Obviously, the ethical cost, the moral cost there is real and noticeable, right? An innocent person was killed. But we could easily imagine that kind of thing taking place in the operational environment. One real world example that comes to mind is an Air Force pilot program, test program that intends to correlate data between weather radar and weather imagery. And so if I have the correlated data of the weather imagery and the weather radar return, then I should be able to train a model to predict what the weather radar looks like if I'm given the imagery. And that is advantageous if you live on a planet that's covered by 70% water, right? Because now I could potentially predict what the weather radar looks like even over the middle of the ocean. And so internally, we were discussing whether this is an ethical concern or not, but we have to ask questions about whether the data, the training data was adequate to replicate or reflect the real world, right? And so we don't think about that as an ethical challenge, but it certainly was an ethical challenge in the Uber case in 2018, right? And now we're talking about a weather radar that maybe has an operational challenge. I just want to give you an opportunity to offer any closing thoughts you have about how we should think about the relationship between ethics and operations as we go forward, as we think about those kindergartners who are someday going to employ these systems.
Yep.
And let's start with you, Bart, if you would.
Sure. Yeah. So the Uber case, I think, is a good one as a foil for U.S. military operations more generally, because the problem is much harder for systems that are going to be working in areas that don't have reliable, consistent road signs, good quality roads, common rules of governance for how to move in and around space. All of those things are thrown out the window when you're talking about military operations. And the way that Uber and all of the self-driving car companies are going about this is to just put miles and miles and miles on these systems so they can find every potential use case in, say, the North American setting, right? That's fine, but our system life cycles don't allow for that. We would drive all of our systems into the ground if we tried to replicate that same side of what I call a data addicted approach. It's no doubt that data is necessary for our current wave of AI capabilities, and that this is where my inherent skepticism for how far current AI systems can go without a human operator. It's founded based on this point. This is why we need the human, because the context changes and the current AI systems are brittle to context. So your point about weather radar and whether that is an ethical issue, I would argue it is, insofar it shapes your decision or ability to operate in a way that fulfills or is within or outside of your ROE. So I think anything that compromises your ability to execute your mission within the ROE and within those guiding principles is inherently an ethical principle. And the seemingly tiniest thing could probably be an ethical consideration if it impacted those. So.
Great, thank you. Mary, over to you.
Okay, a slightly different angle, because I think Bart did a great job covering that, is I think it's unethical to ask a pilot to be a part of a situation that they're not well trained or don't understand their teammates. So I feel like that the Uber, for instance, it wasn't trained to see a woman with a bicycle in a non-crosswalk zone. So it's like, everything it had been trained to do was just kind of thrown out the window. So I believe if you put a pilot in a plane with an unmanned vehicle and they can't predict what the unmanned vehicle is going to do to the point that they can trust it, and they don't have to worry about it, and they know how the unmanned vehicle will react, and they know how they'll react, and they're very well trained. And this, your pilot. So they train to the point that it just becomes muscle memory to a degree, so that the smaller, more regular things you just do without a lot of thought. So you can take your energy and make those decisions. I think you have to train to the point that you can generalize what you know to other situations. And then also, like I said, when I was talking earlier, to be able to transfer that to situations where you've never encountered before. So again, training, make sure people have that calibrated trust in their teammate, and they can meet the challenges head on.
Yeah, that's a great answer and a great insight. This has been a really good discussion. I want to thank you both for taking the time. We've come to the end. I'm 1 minute over. I take full responsibility for that. I won't ask anyone to clap, but I'm sure that we're all very appreciative of Dr. Russell and Dr. Quinn for taking the time with us today. And with that, I'm going to turn it back over to John Askins.
Thank you.
Yeah, thanks for the opportunity.
Thank you so much, Joe, and your fellow panelists. It was a really wonderful, bracing discussion. And thank you everyone who's tuned in today. We covered an unbelievable amount of terrain for a one-day conference, and grateful again to Ron Casey and our partners at Leidos for making this possible. And hope you benefit from it. We will at some point we'll edit up and release the recordings. You can share those, and then I'd be eager. You can write to myself or Paul Schurz if you have any particular responses, and you can look forward to more work from us as we continue this project. So thank you very much.